Hello everyone, in this video I will update you on the new stuff related to FumeFX in the nightly builds of Phoenix FD 2.2 as of the 22nd of July 2014. In short, the atmospheric rendering is faster, the motion blur algorithm is changed and also works faster than the previous one, and there are new render controls for better rendering of Field 3D and OpenVDB files imported from FumeFX and Houdini respectively. First off, rendering smoke and fire will give you on average 50% and up to 2 times increase in speed. Here we have a fire scene with a custom emissive diagram for the fire to gain more detail for the flame. The trick is to use very sharp spikes on 2 or more places and you'll get nicer flames, or you can use the same trick here with the smoke opacity diagram to get the effect of cigarette smoke. You also have to lower the rendering step right here in order to catch the details that will appear. So you might go as low as 20% of the cell size right here. I'm using 50% right now. And also the grid is adaptive, and at the end it goes up to 11 million cells. With the official build of Phoenix 2.2, the first 100 frames take 2 hours and 45 minutes to render. With a nightly build from July 2014, you already need 1 hour and 40 minutes. The speed up will vary with scene, but generally it will be felt. Next thing is the motion blur. With the official build of 2.2, you got more of just a blur and a lot of noise than there was motion in it, and a lot of cases did not work right. Now the basic motion blur algorithm for fire and smoke is completely changed, and here is the result. I'm using V-Ray motion blur with default settings. You have to export the velocity channel from the output rollout to be able to render motion blur. And I have exaggerated the velocity multiplier right here to 5 times to get more motion blur, and also use the negative direction, otherwise with this much increase the fire jet will stretch behind the source. The render time for 100 frames of this simulation with motion blur with the official Phoenix 2.2 build were 4 hours and 25 minutes, and now they have come down to 2 hours and 45 minutes. On to the next feature. There are several new settings to give you more control over the rendering of fire and smoke. First thing, here in this scene we have enabled grid-based self-shadowing, but because we are cutting so much from the emission using our spiky emissive diagram, there is not much light left to illuminate the smoke. We added a setting for the white decay to address such situations. It's physically correct to always use inverse square white decay, and that was the only type in the official build. But if you need the white to travel further, you can set it to inverse or even to none. This way the white power will not fall off with the square of distance, but instead with just the distance travel, or will not fall off at all unless smoke blocks it. If we set it to inverse and render, then this is how it looks. We have added not only more brightness, but more depth as well. I will return it to the default and move on to the next addition. Another new thing is there is a new fire alpha mode. So far the fire opacity could either reuse the smoke's opacity or ignore it and always use full opacity, using a checkbox called ignore alpha that was located right here. If you choose to reuse the smoke's opacity, for example, you could not have fire where there is no smoke. Now we have added a third option, on separate opacity for the fire. If I enable it, right here we get another separate opacity multiplier for the opacity diagram and another fire multiplier for the color. This way you can make layers of fire obstruct each other and behave more like colored smoke, thus giving fire more depth and better feel for volume. Of course it still has its ability to shine, which makes it different from the smoke. Okay, so let me illustrate that by making the emissive color deteriorate with increasing temperature. I will add a couple of reference points at the beginning and the end, and another point here with black color. I will also make the opacity increase with temperature. I will delete some of these points and drop this below 0, and I also modify the multipliers. I will set the fire multiplier to and keep the opacity multiplier. Alright, and here it is. I will also return back to a more interesting frame, render again. Here it is. I will decrease the opacity multiplier to show deeper layers of fire. I will set it to 0.4. Render again. Okay, and to make it more interesting, I will curve up the opacity right here. Okay, I will make the bottoms wider. Alright, render it again. Okay, and if you need more detail than that, you can just drop the bottoms of these volleys right here below 0 to get sharper spikes at the top. Okay, and I will also further decrease the opacity multiplier to make it more transparent. Alright, and here it is. And here's the entire sequence with these settings. The render time has decreased. Now we render for only 1 hour and 55 minutes with motion blur, although with just a negative multiplier of 1 instead of 5. The reason we got a small speed up is because in the first two fire opacity modes, the fire only contributes cover but no opacity. Since our smoke is so thin, with a simple smoke factor of 0.03, the rays traversing our smoke could go all the way to the back of the smoke cloud without stopping. In our new mode, the fire contributes not just cover but opacity as well, so it's much more probable that a ray will reach maximum opacity and quit earlier before reaching the back of the smoke cloud. And so this will help increase performance a little. And the same rule applies just for smoke as well. So the lower the transparency, the faster it will render. Okay, so the last thing we added to the rendering is a means to control the way light penetrates the smoke. In the official build, you could only change the smoke cover right here, or the smoke thickness right here from the simple smoke factor. But if you needed to make brighter highlights, or in general to add more diversity, you would always be stuck in a compromise. We have now added controls for how much the analytic light scattering goes into the smoke, so you can achieve a better sense of volume without altering the opacity. If I disable the fire in order to see the smoke better here in the GPU preview, I will also raise the detail by decreasing the reduction, and here's the smoke that we have right now. If I want to make brighter highlights here, I could try raising the simple smoke factor to increase the density, but this way we would cover the fire inside the smoke and make it not visible. So now return this back to 0.03, and the other thing to try is to generally increase the cover of the smoke, or here the brightness with the multiplier. Okay, but this way the entire smoke gets brighter. So what I'm going to do is just again increase the smoke cover but decrease the external scattering boost right here. This way we will decrease the scattering, light will enter the smoke brighter but will fall off quickly. Okay, so if I further increase the cover right here and drop the scattering boost furthermore, now you see that we get a lot more details for the smoke, and we still have our fire visible inside it as it was before without obstructing it, which we would have done if we increase the simple smoke factor. Okay, so for on white right here with the on white scattering multiplier, this could be used for fine-tuning of the emissive light propagation if you need something between the, for example, the inverse square or the inverse decay type. If you need to fine-tune this between these, you can always use the on white scattering boost and increase it further. So that's it for these options. And now to the final part of the video. Using these controls you can get better renders of imported cache files from FumeFX and Houdini. I will show you how to adjust the render settings to match one of the FumeFX sample scenes, the Taurus in Fire sample scene, and I will leave the Houdini import to you, as it works basically the same way. I will only mention that there are tutorials online on how to export VDB caches from Houdini, And the only restriction on the Phoenix side is that you have to use at least 3ds Max 2010 or newer to be able to import VDBs in Phoenix. So, how do we do this with FumeFX? First off, you need to make FumeFX export H3D files from the default cache path. Here it is. And here you have to set it to field 3D file. One more thing I have to mention is that you have to go here to the preferences and set the field 3D compression to gzip. Cache files with the proprietary FumeFX compression will not open in Phoenix. One more thing I need to mention before we continue is that you have to go to the rendering tab and disable the fluid mapping because it does not get exported to field 3D. So, after the scene is simulated, I have done this beforehand, we can check the original render. Here it is. I will just zoom in a bit. Alright, and I will change the renderer to V-Ray. Changing the renderer requires that I go and also change the shadow type to V-Ray shadow. Alright, and I will render this frame again. I will also disable the gamma correction. And here it is. This is our reference frame. So, we can now go ahead and create a Phoenix simulator. Here it is. Importing Field 3D files happens here from the input tab. You select the cache path. You can choose between the usual Phoenix Aura files, the F3D files, and the OpenVDB files. So here they are. I'll just double click it and it is imported. Here you can see that it changes in the timeline. But another thing you have to do is to adjust the position of the simulator. Right here, I will copy it from the FumeFX container. Alright. And here we go, now they match. Now you can check the channel list right here under the simulation rollout. Here the cache file content list shows that you have smoke, velocity and fuel. Beware that the FumeFX fire channel translates into the Phoenix fuel channel so that it will be rendered properly. Now, the easy way to start with the rendering and viewport preview settings is to load the Phoenix settings preset. From here, the Phoenix installation comes with presets for Houdini and FumeFX that mimic the default render settings of each respective software. The presets along with the Phoenix sample scenes should go into your documents folder after install. But if Windows prevented them from installing due to problems with permissions, for example, you can always download the presets and sample scenes from the help site, which you can open by using any of the buttons with question mark around the Phoenix simulator rollouts. Okay, so I will load the FumeFX preset. Here it is. And we get the viewport preview and we will get the default rendering settings. So right now, if I want to render the Phoenix simulator, I have to go to the environment and effects dialog and disable the FusionWorks renderer. Just leave Phoenix FD enabled. And if I hit render, right now we'll see that we get a much different results because we are using just the default FumeFX settings without any change. Okay, so I will cancel this for now. And we will go and start altering the options to match the look of FumeFX. So first thing, you have to make sure that the use zone opacity fire opacity mode is selected right here. Next thing is I will turn off the emissive whites for now, but they are present, you will get when importing from FumeFX to Phoenix. So right here you can see that the fire is also illuminating the geometry around the simulator, but I'll disable this for now just to get the exact same effect of FumeFX or as close as possible. So let's get to equalizing these two. first thing we need to do is to set the render step size. So I will go to the properties of FumeFX. I'll just pin this for now, and we can see that the step size is 20%, the step size in Fire is 10%, so I will just set the Phoenix step size to 20%. This will do for now. There's just a single step control in Phoenix FD, as opposite to the separate step size and step size in Fire in FumeFX. So you get to choose what step suits your best, and you can optimize it. Then I will turn off Fire for both of these. Here we go. And I will render just the smoke. So here is the smoke with the Phoenix renderer. Okay, I will copy this. I will just close this one because we have too much open, and I will switch to the FumeFX renderer and render again to see the smoke that we have to get. Okay, so what are the differences between our options? Here the smoke color is white. The same goes for FumeFX, so no change needed here. In Phoenix I will raise the simple smoke factor to about 0.5. For example, you can see that right here the FumeFX uses another scale for opacity, and I will also decrease the scattering. Okay, so I will switch back to the Phoenix renderer, and here it is. Okay, so and on to the next step, to equalize the fire. I will enable the fire on Phoenix, disable the smoke, and I will do the same thing for FumeFX. Okay, switch renderers again, and let's see what the fire in FumeFX looks like. Alright, so this is what we're aiming at. I will just copy this. I will close the rendering dialog. So let's see what our differences are. Okay, so I will use the fuel channel, which is the appropriate. This is the fire channel. Okay, so here is our diagram, and here is the diagram of FumeFX. You can see that it's quite a lot thinner. So I will try to mimic it as well. Okay, so I will push back the handles right here to get these sharp shapes. Okay, and also I will decrease it to about 0.088, which is the actual scale that that FumeFX has. I don't know why there is a tenfold difference. Okay, and it should be something like that. Okay, so the next thing, the opacity multipliers, they correspond directly between Phoenix and FumeFX. Whoops, here we have to change the renderers, otherwise of course we will get the absolute same result. You can see that we have a different color for the fire right here. Okay, so it's 255, 123 and 43. Okay, now the color is equal to, and we see that the strength of the fire needs to be reduced, so I will turn the fire multiplier down to 0.6 for example. Okay, and maybe furthermore. Okay, and that's it. So now if we enable the smoke for both Phoenix and FumeFX, so I will turn it back to constant color right here, just to use this color. We don't have any opacity map for the smoke, and the same goes for FumeFX. And if I render the FumeFX scene right now, this is the result that we're aiming at. I will copy it, switch back renderers to Phoenix, and render again. You can see that we have our grid-based illumination enabled by default. This corresponds right here to the Illume tab of FumeFX, to the multiple scattering section. So this is our result. Here you can see that there's still a bit more tweaking to do, but in general this is the basic workflow you can use. And if you're working on a lower resolution, like this scene for example, you might smooth out the grid artifacts that you get right here. You can see that FumeFX has them too, by changing the rendering sample in Phoenix from linear to spherical. Okay, so you can see that these got smoothed out. This will take a bit of extra time to render, so if you're working on a higher resolution, than say higher than 20 million, the grid artifacts will probably no longer be noticeable with the linear sampler. So you may then roll back to it and get some render speed improvement. Okay, and one last thing I want to mention is the motion blur. If you want to render motion blur in Phoenix, you have to enable the velocity export, as you can see that I did here previously, and you have to enable it from FumeFX when simulating your few 3D files, and then after importing you may play with the velocity multiplier right here in the Phoenix render settings, because FumeFX and Phoenix velocities are in different units and you may get too little or too much motion blur with the default. So in this case I will reduce it to 40 because we will get too much. I will also change the sampler back to linear to render a bit faster. Whoops, and I have to enable motion blur. Okay, so here it is, and to get rid of the noise I will go and decrease the maximum subdivisions of the adaptive sampler to 8 and render again. Alright, so here it is. I will maybe just decrease the velocity multiplier furthermore, and I'd like to thank you for watching. Until next time.